I was expecting that storing passwords the right way is common knowledge by now for most software developers. Yet, I still encounter websites that don't do it properly. How do I know this without looking at their source code? They send your password by email when you forget it. And I am not talking about the temporary generated one, but the actual password which was used during registration. So here is a video on how to properly store passwords. First, I must add that it is better and wiser to use a third-party service that is specialized for this. There are many alternatives like Keycloak, Citadel, or Auth0, which provide authentication functionality with zero friction and small footprint for your application. Or just use Login with Google and be done with it. Still, knowing how to store passwords is essential, so let's look at 4 methods of doing it, from the worst to the best. Method 1 involves storing the passwords in clear, directly in the database. Never, and I mean never, do this. In case your web app has a data breach and your database is exposed, all your passwords are clearly visible. And since the vast majority of users reuse passwords, you just compromise their accounts on many other platforms as well, not just your own. Method 2 is a bit more secure but still not good enough, using a simple hash for the passwords. While some hashes are better than others, it is still not enough to properly secure your stored passwords. This is because there is such a thing as a rainbow tables attack. This is a simple attack where, once your database is compromised, the attacker uses a big file called a rainbow table that contains known hashes for a big number of passwords. It is only a matter of matching the hashes from your database to the known ones. The attacker won't manage to find all the passwords, but most of them will be guessed this way. Furthermore, if multiple users have the same passwords, they will have the same hash, which greatly reduces the time needed to guess all the passwords from your system. Only now, once we reached the third method, I believe we reached a secure way of storing passwords. This method involves salting the password prior to hashing it. A salt is a random string which is unique for each user and which is being used with the password when hashing. In simple terms, a salt is generated prior to hashing the password. Then, the salt plus the password as a concatenated string is sent to the hashing algorithm. Both the resulted hash and the salt are stored in the database. Now, even if you have a breach and the database is exposed, the passwords are safe. Because the salt is different, each user will have a unique hash even if the passwords are the same. The passwords are also protected from rainbow tables attacks since the salt adds randomness to the inputs, and ideally they should be long, making it impractical to generate known hashes. Now, the database contains both the hash and the salt. So, if someone truly wants to find the password for a user, he may be able to do it, but it will be very time consuming and impractical of doing it for more than a few, maybe high profile users. How can we make things even more secure? By adding even more randomness. And this randomness is not stored in the database. This is called a pepper and is another random string that gets prepended to the password prior to hashing it. The pepper is not stored in the database, but in a configuration file. The paper is generated once and it is the same for all users. It is written in a configuration file of your application and used when hashing. This way, even if your database gets leaked, the attacker won't know the paper unless he somehow manages to get full access to your system, in which case you have an even bigger problem. Now, let us look at a simple code example. I have here a method in Java that generates a hash for a password. It has as input parameters the password, the salt, and the pepper. Because we are using hashing algorithm, we can throw two exceptions. no such algorithm exception, and invalid key spec exception. Now, using the secret key factory, we get an instance of our algorithm. In this case, I am using pbkeydf2 with hmac and SHA-512. This is a rather secure hashing algorithm with no known vulnerabilities. And using our key factory, I create a key spec that has the password plus the pepper concatenated, the salt, and we provide the number of iterations and the hash byte size. These two variables can be configured to make it more strong uh, or to make it so that it takes longer or shorter time. The bigger the number of iterations, the longer it will take for the hash to be computed, which is good for security, but you don't want to make it too complicated because then the user will take too long to log in into your system. Finally, using the secret key factory, we generate the secret using our specification, the PB key spec that we instantiated earlier, and we encode it to obtain the hash as a byte array. Finally, we return this byte array as a base64 encoded string. As you can see, it is quite easy to store passwords properly in the database. You are not actually storing the password, but a hash that is computed using random elements. Next, when you want to validate that the user submitted the correct password during login, you just recompute the hash using the known random elements. You have the submitted password, you have the salt in the database, and you also have the pepper in the configuration file. You recompute the hash again, and if the resulted hash is equal to the one stored in the database, then the user entered the correct password. Otherwise, the user entered an incorrect password and should not be granted access. You can read more about this on my blog, where I have two dedicated articles. One of them covers hashing passwords using only a salt, and the other one using a pepper as well for better security. That's it for now. I hope you enjoyed this lesson, and I hope I'll see you again next time.